So it's time for our class.
Yes, 老师。
So
Okay,
how many
老师。
students today? How many students today? I remember 40 students last class. So by the way, I noticed only one student sent the homework to my email. Can you?
Only one student? Are you sure?
I also send you
Yes.
in
Only
WeChat.
one student, 老师。
老师 can
Only
you show
one,
please?
only Omar.
Oh my
Hmm?
goodness.
Submit
I
the homework through email, not WeChat.
老师 I
Oh
sent
my-
you email the same day.
I sent also 老师 by email.
I also send your email.
Can you recheck
Up
it
to
now?
now, I will check it later. I checked it last night. I only see Omar send the homework, and this morning one student sent the homework through WeChat. But please submit the homework through WeChat, through the email. So the deadline of this work of the homework is tomorrow. So anyone want to submit homework? Please send it to. Oh,
老师 I sent the homework May
not
13th.
WeChat, not WeChat. So
Yeah, from your email, 老师。
email.
3 days
Some
ago.
of us 老师。
I will check it later. And okay. If you have submitted, I will see it. Don't worry. So let's start this class. Last Friday we have learned the procedure of process planning, including process rule and its function, and the four aspects of the functions, and then the selection of location data, including the datum definition, the classification of data, including design data, process data, and how to select the location data. And I have told you lot of principles, including principles of selecting the rough data, principles of selecting the finished data, and so on.
You didn't share the screen.
You cannot see the screen? Can you see this one? Determination of machining allowance?
No.
We cannot see
No.
老师。
You can't see anything?
No, nothing.
Sorry. I will. Oh, sorry. So today's Today's work, our business is the determination of machining allowance. The first thing we will know is the concept of machining allowance. In order to achieve desired machining quality, redundant material of a workpiece or a blank should be removed. This thickness of the removed material from a surface of workpiece or blank is called machining allowance. So as the sentence say, the thickness of removed material of a surface of a workpiece or blank is the machining allowance. So this is the definition, and we will see the machining allowance through a video.
We're at work by
Build custom industrial machines in days.
Todd, he is emailing a difficult client.
Design a machine in the simplest online
Machining allowance. Let us see an example for machining allowance. This is the dimension as cast. This is the dimension required. Boring operation take place by using boring tool. It is a positive allowance given to compensate the amount of material lost in machining for finishing the casting. Milling operation takes place. If this allowance is not given, the casting will undersize after machining. This allowance value varies from 3 mm to 18 mm.
So this is the video. Allowance is
Shrinkage allowance. Let us see an example for shrinkage allowance.
machining allowance is the thickness of removed material from a surface of a workpiece or a blank. And the machining allowance can be divided into total machining allowance, and operation allowance. In the machining allowance process, from the blank to the finished product, the total thickness removed from a surface is called the total machining allowance of the surface. The total material thickness removed from a surface is called the total machining allowance. It equals the difference between the blank dimension and the design dimension of the part join. So the total machining allowance is the total material thickness removed from a surface. It equals the difference between the blank dimension and the design dimension of the part join. It equals the difference between the blank dimension and the design dimension of the part join. The material thickness removed from a surface in one operation is called the operation allowance, and it equals the difference between the dimensions of two adjacent operations. That you say, for example, the operation allowance is the first step of first operation, and the second operation, the material thickness.
Your work can feel much smoother with Monday.com WorkOS. This smooth. All you need to do to get started is choose one of our templates, add your teammates, and that's it. You can manage all your work in one place, even work from other platforms. Just start using it. It's super intuitive. Oh, and if you don't like something, just change.
The surface to be machined is referenced by a surface finish symbol that indicates material removal is required. This symbol is either accompanied by a machining allowance value or information in the notes section. A machining allowance note will typically provide a default machining allowance amount, surface finish roughness value, or other specification for the surfaces bearing the symbol. The presence of the symbol in the machining allowance note indicates that an area on the casting requires extra machining stock, which refers to extra material that is added to a specific location. On this casting drawing, when section CC is overlaid with the same section from its machining drawing, it is revealed that there is extra material. When it comes time for this piece to be machined, machining operations will remove the extra machining stock so that the piece may meet the manufactured requirements.
So we have seen video about machining allowance again. So up to now, we have learned the definition of machining allowance. It is the thickness of removed material from a surface of a workpiece or blank, and it can be divided into total machining allowance and operation allowance. While the total machining allowance is the material thickness removed from a surface. It's called the total machining allowance. It is the total material thickness removed from a surface. It's called the total machining allowance. And the operation allowance is the material thickness removed from a surface in one operation is called the operation allowance. So what is the relationship between total machining allowance and operation allowance? The relationship between the total machining allowance delta Z0 and operation allowance delta Zi of a surface can be calculated like this. Where the n is where variable n represents the number of operations for the surface, and delta Z0 denote total machining allowance, and delta Zi means I's operation allowance, which means this equation can be yield out by the definition of total allowance and machining allowance, while the total machining allowance equals the difference between the blank dimension and the dimension of the part join, which means the total material thickness removed from a surface. A total material thickness removed from a surface. And the total machining allowance must equals to the summation of operation allowance. For example, in this equation, it contains n operation allowance, and the total operation allowance equals to the summation of the n operation allowance. So if we want to calculate the total machining allowance, and we must know the every operation allowance in the machining process, and we plus every operation allowance, and then we will get the total machining allowance. So the total machining allowance can be calculated directly based on the operation allowance, simply by the summation of the operation allowance. So we have then the machining allowance, and the next question is, what are the factors of affecting machining allowance? In engineering, generally under the promise of guaranteeing the machining quality, the machining allowance should be as small as possible. But how large the minimum machining allowance should be, it is necessary to analyze the factors which affect the machining allowance. Under the promise of guaranteeing the machining quality, the machining allowance should be as small as possible. For manufacturer consideration, but how large the minimum machining allowance should be, it is necessary to analyze the factors which affect the machining allowance. And the first one is the surface quality of previous operation. The first factor which affect the machining allowance is the surface quality of previous operation. Surface quality of previous operation. The surface roughness and the defective layer left on the surface by previous operation have to be removed by the current operation. The first factor is surface quality of previous operation, because the surface roughness and the defective layer left on the surface by previous operation have to be removed by the current operation. Generally speaking, it means everything left on the surface by the previous operation will be removed by the current operation. Therefore, the surface quality of previous operation is an effect which will affect the machining allowance. And the second factor is dimensional tolerance of previous operation. While the dimension tolerance is represented by TA. which means dimensional tolerance of previous operation. In order to correct the machining errors produced in previous operation, the machining tolerance of this operation should include in TA. In order to correct the machining errors produced in previous operation, the machining tolerance of this operation should include the previous dimension tolerance. The magnitude of TA can be found by looking up the relevant handbooks based on the economical machining accuracy. Repeat again, the second factor affect the machining tolerance is the dimensional tolerance of previous operation, and the dimension tolerance is represented by TA. So why the dimension tolerance of previous operation will affect the current machining tolerance? It is because in order to correct the machining errors produced in previous operation, the machining tolerance of this operation should include TA, should include the dimension tolerance of previous operation. And the magnitude of TA can be found by looking up the relevant handbooks based on the economical machining accuracy. The second factor is separately considered space error left by previous operation. So the three factors is the previous operation, which means the previous operation have significant influence on the current operation. And the third factor is separately considered space error, though A left by previous operation. Space error, though A, means some form and positional errors which are not included in the limit deviation of dimension, such as straightness, centricity, and panelness, and so on. These kinds of errors should be removed in the current operation, and the value of rho A is related to the previous machining method. The third factor is separately considered space error left by previous operation. Because space error means some form and positional errors which are not included in the limit deviation of dimension, such as straightness, centricity, and so on. These kind of errors should be removed in the current operation. The space errors rho A should be removed in the current operation, and the value of the space error rho A is related into the previous machining method. So have learned three factors which will affect the machining tolerance, and the three factors all are concerned the two previous operations. The first one is surface quantity of previous operation, and the second one is dimensional tolerance of previous operation, and the third one is separately considered space error left by previous operation, which can be seen. The previous operation have significant influence on the current operation, and the last factor is the installation error of current operation. which is represented by this one, Ipsen B. The installation arrow consists of location arrow and a clapping arrow. It will directly affect relative position between the surface to be machined and the cutting tool. Repeat again. The installation arrow consists of location arrow and a clapping arrow. It will directly affect relative position between the surface to be machined and the cutting tool. The installation arrow consists of location arrow and a clapping arrow. It will directly affect relative position between the surface to be machined and the cutting tool. So up to now, we have learned the concept of machining allowance and the two kinds of machining allowance, which include total machining allowance and operation allowance, and the total machine allowance can be calculated by the summation of operation allowance, which can be calculated by this equation. And then we have learned the factors affecting machining allowance. We have introduced 4 factors, and the first 3 factors, which are related to the previous operation, and the last one is the installation arrow of current operation. So we have learned the concept and the factors affecting machine allowance. The next question is how to determine machining allowance. What are the methods to determine machining allowance? As we said, the machine allowance should be as small as possible. But how large the minimum machine allowance should be, and what the methods to determine machine allowance? And this is the methods. The first method to determine machine allowance is by calculation. Theoretically, scientific and rational machine allowance can be determined by means of this method. But there must be reliable experimental data. It is not widely used at present. Sometimes this method is used in the K operation, in large volume and mass production. The first method is by calculation. Scientific and rational machining allowance can be determined by means of this method, but this method needs reliable experimental data. It is not widely used at present. Sometimes this method is used in K operation, in large volume and mass production. The first method is by calculation. And the second method is by looking up tables. Combining with some specific machining method, the machining allowance is obtained by looking up the handbooks for machining allowance, machining process. If necessary, the data got from handbook should be modified. This is the simplest and most common used method. The second method is by looking up tables, and this is the simplest and most common used method. This is the most common used method. So the question will come out, what is the most common used method to determine machine allowance? The answer is by looking up tables. The next one is by experience. Machining allowance is determined by experienced engineers, techniques, or workers. This method is mainly used in job or small batch production. Mainly used in job or small batch production. And the first one by calculation, which is used in the key operations of large volume and mass production. And the by experience method is mainly used in job and small batch production. So that we have then the three methods to determine machine allowance, and the first one is by calculation. Theoretically, scientific and rational machining allowance can be determined by means of this method, but there must be reliable experimental data. It is not widely used at present. Sometimes this method is used in the key operation in large volume and mass production. And the second method is by looking up tables. This is the simplest and most common used method. This is the most simplest and most common used method. Because combining with specific machining method, the machining allowance is obtained by looking up the handbooks of machining process. If necessary, the data got from handbook should be modified. And the last method is by experience. Machining allowance is determined by experienced engineers. This method is mainly used in job and small batch production. So we have then the determination of machine allowance. The first one we have then the concept of machine allowance. Well, the machine allowance means the thickness of removed material from a surface of workpiece or blank is called machine allowance. And it can be divided into total machining allowance and operation allowance. And the relationship between total machining allowance data Z0 and operation allowance data Zi of the surface is calculated by this equation, where the total allowance is calculated by the summation of operation allowance. And it is yelled out by the definition of total and operation allowance directly. Then we have the factors affecting machine allowance, including 4 factors. The first 3 are concerned to the previous operation And the first one is surface quantity. Second one is dimension tolerance. And the third one is separately consider surface area. And the last one is installation area. And the next question is the methods to determine machine tolerance. We have mentioned 3 methods. First one by calculation, second one by looking up tables, and the last one by experience. And every method has have the definitions. And the first one is by calculation is used in the K operation in large volume and mass production. And the second one, by looking up tables, this is the simplest and the most common used method. And the third one is mainly used in job as small batch production. Remember the features of each method and what time we use which method to determine machine tolerance is the key point of this class. So the next class will be a small difficult, which comes to the determination of operation dimension and its tolerance. And the first one is the dimension chain. Dimension chain, and we will learn how to draw the dimension chain, and maybe it's a small difficult process. In the machining process of a workpiece, workpiece dimensions are gradually changed from the blank dimension to each operation dimension, and finally to the design dimension. To reveal the relationships of the related dimensions by means of dimension chain theory is very important for determining each operation dimension and its tolerance reasonably, and ensuring both machining and assembly quality. The dimension chain method is an effective tool used to analyze and calculate operation dimension in process planning. So have learned the process planning, and the dimension chain is an effective tool used to analyze and calculate operation dimension in process planning. Dimension chain is an effective tool used to analyze and calculate operation dimension in process planning. Analyze and calculate the operation dimension in process planning. Because in the machining process of a workpiece dimensions are gradually changed from the blank dimension to each operation dimension, and finally to the design dimension. To reveal the relationships of the related dimensions by means of dimension chain theory is very important for determining each operation dimension and its tolerance reasonably, and ensuring both machining and assembly quality. The dimension chain method is an effective tool to analyze and calculate operation dimension in the process planning. So it is key point of dimension chain. So what is the dimension chain? In product design and manufacturing process, some related and dependent dimensions are usually concerned. Dependent and related dimensions are usually concerned. Dimension chain is a closed dimensional diagram which is composed of a group of related dimensions connected in end-to-end sequence way. So definition is dimension chain is a closed dimensional diagram which is composed of a group of related dimensions connected in end-to-end sequence way. End-to-end sequence way. This time we will see the dimension chains or video because this is a very important concept.
Win at work by communicating effectively. With Grammarly, meet Ty. He is
In this video, I will show you how to draw dimensioning chains in 3D Studio Max, like in 3D programs. This feature is a part of the workspace Digitales Entwerfen. You can download it from the internet page designstrategies.org. The plugin is based on a plugin of Borislav Petrov, and it's nicely reworked by Kostadin, Kotev, and thanks a lot. You can see that I already do some dimensioning lines, and if you draw dimensioning lines or dimensioning chains, they will be stored in one.
What the student's number of this student, 端泽 Sally, the monitor. So no one responds to me.
On a layer,
Laoshi,
the dimensioning layer.
So who is 端泽?
I mean, like, Sally, his micro is not working.
So do you know this student?
Which one?
This one?
No, actually, I don't know.
Okay, maybe it's, I don't know what is his student number. So okay, let's continue the
You
class.
can just see it in my layer manager. If I just select all my files, then I can just delete this. This is the toolbar of Digitales Entwerfen, and you can see all the features of my dimensioning tools. If you just select everything, then you can just go and just say delete, demaster, and you just see that only my dimensioning chains are deleted and everything stays. Okay, let's start. First, I will show you the really basic settings. I just draw a little bit like a three-dimensional floor plan. You can just see this kind of object, and we will play with this. And I just go into my top view, and I just use my create multiple horizontal or vertical dim lines. I just choose this, and what it does, I can just go to the first vertex point of my object and move to the right direction and click another time. And if I want to finish this dimensioning chain, I just right mouse click and finished my tool. After I created it, I can move it up and down. You can see it like this, and it doesn't matter which point you choose. You can always create a horizontal or vertical line. I'll just do it again. And I click this point, I click this point, I click this, and this. I just close it with right mouse click, and I just move it up, and you can just see that it's again a straight horizontal line. You can also do this in vertical direction. I just go again here and just click this point, and I just click this point, and now you created a vertical dim line.
Okay, maybe this video is too long, and maybe we will see the video if we have enough time. So the dimension chain is very important in our class of this book. So I will repeat it again, the definition of dimension chain, and then maybe I will raise a question, and some students maybe answer me.
Okay, 老师。
The dimension chain is an effective tool used to analyze and calculate operation dimension and in process planning. And the dimension and the definition is a dimension chain is a closed dimensional diagram which is composed of a group of related dimensions connected in end-to-end sequence way. So it has some key points of the definition. The first one is the closed dimension diagram. It's a closed one, the first key point. And the second is it is composed of a group of dimensions. The second one is not only one, but composed of a group of related dimensions. And the last one is it is an end-to-end sequence. So the definition chain has three key points. The first one, it is a closed dimensional diagram. And the second one, it is a group of related dimensions. And the third one is it is an end-to-end sequence way. So can anybody tell me what the definition of dimension chain and what's the key point? I will choose one.
Yes, 老师 again.
Yes, 老师。
I noticed only one female student in your class. Can you answer the
老
question?
师 I'm here.
老师 I can answer the question, 老师.
I want the only female students answer the question. Yang Lian, do you name the Yang Lian?
老师
Hey, please answer the question. Can you answer the question? I can hear you.
Can you hear me?
Yes, I can hear you. So please answer what's the definition of dimension chain and what's the three key points of dimension chain?
A dimension chain is a closed dimension diagram which is composed of a group of related dimensions connected in end-to-end sequence way.
Yes. So what's your student's number?
61, 老师。
61. Okay.
Yes.
No, it's 90, 老师。
Huh?
It's 61. What is wrong with you?
Oh, I didn't see.
No, it's very good. And
Thank you,
anyone
Laoshi.
answer the
61.
question, maybe contribute to find the score. It's only, sorry, PPT wrong.
61, 6 and 1.
Yes, I remember it and I write it down.
Thank you, Laoshi.
So we have then the concept of dimension chain and have learned three key points of the dimension chain. And the students under the question seems like everyone had noticed, had paid attention to the dimension chain. So let's continue. Oh, it's time to have break. 20 minutes later. See you at 9:10.
Okay,
See you.
Laoshi, can you at least check the people sent the homework, please?
Okay, I will check it now. And I will tell you at the beginning of the next class at
Okay,
9:10. Okay.
老师, we cannot hear anything.
Sorry. I have said a lot, but you hadn't heard anything. Can you hear me now?
It's okay, 老师.
Yes,
Okay. The first question I have received all of the homework because the homework have go to the dustbin, and I have seen the homework of you if you submit the homework by email. I have received.
Okay, thank you, Laushi.
Maybe 30 students, maybe.
It's possible for you to confirm this name Lava if my homework is there. Please. 70, my last number.
You wanna?
Yeah,
okay,
because
I can see.
Just to make sure.
Sorry for a moment.
Okay.
So what's your number?
70. Last number.
70.
Okay. I submitted, Lapsi. Yeah,
okay,
guys.
okay.
Yeah, up one.
Okay.
Okay, thank you.
So let's continue the class.
Sure.
We have the definition of dimension chain, and it consists of 3 key points: closed dimensional diagram, a group of related dimension, and end-to-end sequence. And a dimension chain is composed of a closed link and a several component link. The last form the dimension in assembling process or machining process is called the closed link. It is the last formed dimension. The last formed dimension is called the closed link, which is denoted by A0. There is only one closed link in a dimension chain. Only one closed link in the dimension chain. It is the key point of dimension chain, and it is the last from the dimension in assembling process or machining process. For example, this is the assembly dimension chain, and the symbol A0 represent the closed dimension chain because it is the last formed dimension in assembly process or in the machining process, because we process A2, A0, A5, and A4, and the dimension as A0 comes out naturally. We can compute A0 by A3 minus A2 minus A1 minus A5 minus A4, and we get A0. It means it means the A0 is the last formed dimension in the process, in the machining process. It can be calculated by A3 minus A2, A1, A5, and A4, and then the A0 comes out naturally, which means it is the last formed dimension in the assembly process or machining process. Is called the dimension, the closed link. And as shown in this figure, is only one A0 in this figure, and which means there is only one closed link in the dimension chain. All of the dimensions which have an effect on the closed link in a dimensional chain are called component links, which means it can be obtained directly. We can, in this figure, I will see it again, repeat it again. All of the dimensions which have an effect on the closed link in a dimensional chain are called component links. So in this figure, the A0 is the closed dimension, and all the other dimensions, which means A1, 2, 3, 4, 5, all have an effect on the closed link A0, which means A1, A2, A3, A4, A5 are the component links. The component links A1, A2, 4, 5, 3 can be obtained directly. Usually, the component links are denoted by A1, A2, 3, A4, A5, and AN-1, AN, if we have many. If we take the closed link into consideration, then the component link may be calculated as AN plus N-1. In addition, component links can be further divided increasing links, increasing with an arrow to the right side. The component links can be further divided into increasing links, denoted by this symbol, and decreasing links. This one, a symbol, an arrow to the left direction. Suppose other components are constant. Suppose other component links are constant. If the variation of a component link would lead to the variation of a closed link in the same direction, the component link is named as the increasing link. What does it mean? Take this for example. If the dimension of 3, the dimension of A3 is a component link. If A3 increasing, then the A0, the closed link, will increasing. It will be increased at the same time, which means we call the A3 is the increasing links. A3 is the increasing links because when A3 increasing, the closed link A0 will be increased. So the definition of increasing links is: suppose other component links are constant. Suppose A1, A2, A1, A4, A5 are constant. If the variation of a component, for example A3, if the variation of a component link would lead to the variation of a closed link A0 in the same direction. For example, when A3 increasing, then A0 increasing, the component link A3 is named the increasing link. So in this figure, for closed link A0, A3, the composed link A3 is the increasing link, which can be represented by this one, A3, increasing link. If not, the component is named the decreasing link. For example, if A3 is a constant, when the component link I2 increasing, then I0 will be decreasing. So for I0, for I2, I0 is a decreasing link. The decreasing link is denoted by this symbol. So I will repeat it again. Suppose other closed link component links are constant. If the variation of a component link would lead to the variation of a closed link in the same direction, means increasing at the same time, decreasing at the same time, then the component link is named the increasing link. If not, the component link is named the decreasing link. For example, in this figure, if A2, this dimension is the closed link. For example, if A2 is a closed link, and then A1 is an increasing link, and I3 is a decreasing link. If I2 is a closed link, then when I1 increasing, the closed link I2 will increasing. So I1 is an increasing link. I1 is an increasing link. Meanwhile, when I1 is a constant, I2 is a closed link, then when I2 increasing, which means I3 will vary in the opposite direction, which means I2 increasing because I1 is inconstant. When I2 increasing, then I3 must decreasing, which means I3 is a decreasing link. So we have explained the decreasing and the increasing link many times. So we have learned the concept of dimension chain and the increasing links and the decreasing links. The next question is classification of dimension chain. So what's the classification of dimension chain? The first one, classification according to the function of dimension chain. Classification of according to the dimension chain.
老师 is it about the decreasing and increasing, right?
Yes, about increase and decreasing.
Okay.
And then,
for the first diagram, we have the A0, which is equal to the A3 that minus A1. Oh, A minus
yes. Oh, yes.
And then
in this figure, I1, you can see this figure. I1 is equals to I2 plus I3.
Yeah.
You understand that?
Yeah.
Okay. Yes. When I1 is a constant, I2 is a closed link. I2 is a closed link.
And
Yes,
then
they
when the
I3 and I2 maybe because their summation is constant. The master variation is opposite direction.
yes,
Yes, to
yeah,
so therefore to I2, I3 is in decreasing link.
decreasing link, yes,
Yes. Also in this figure, I3,
yes. When
yes, yes,
A3 is increasing, the A0
yes, yes, yes,
increasing too.
yes. Okay, okay.
Mm.
So the classification, let's come to the classification of dimension chain. The first one is classification according to the function of dimension chain. The first one is technical dimension chain, technological dimension chain. The dimension chain formed by some related dimensions of the single component in machining process is called the technological dimension chain. The dimension chain formed by some related dimensions of the single component in the machining process is called technological dimension chain. The first one is a technological dimension chain. We have this example. In the last figure, dimension chain is formed. The first one in classification is the technological dimension chain, which means the dimension chain formed by some related dimensions of the single component in the machining process. We have seen this figure, which means the dimension chain formed by some related dimensions. Some related dimensions I1, I2, I3, the some related dimensions of the single component in the machining process is called the technological dimension chain. The dimension chain formed by some related dimensions of the single component in the machining process is called the technological dimension chain. And the second one is assembly dimension chain. We can figure it out by the name assembly dimension chain. It is formed by some related dimensions of different component or part in assembly process. So it can be explained by the definition, by the word assembly. It is formed by some related dimensions of different dimension of different component or part in assembly process. The opposite to the first one, technological dimension chain, which is some related dimensions of a single component. And the second one, assembly dimension chain, it is formed by some dimensions of different component or part in assembly process. Many components, many parts in the assembly process. And the third one is design dimension chain, which it means it is formed by some related dimensions in a part design join, which can be explained by this word design. It is formed by some related dimensions in a part design join. The design dimension chain is in the design process. And the second what?
Laoshi, sorry, please, can you repeat the last one that you say? It's formed by some relative dimension in a path sign. What?
Okay,
The
I will repeat
design
it again.
dimension chain.
The first classification method is classification according to the function of dimension chain. I will repeat it again, all of the point. The first one is typological dimension chain, which means the dimension chain formed by some related dimensions of the single component in machining process. Which means the dimension chain, the first one, which means the dimension chain formed by some related dimensions of the single component in machining process is called the typological dimension chain. And the second one is assembly dimension chain. It is formed by some related dimensions of different component or part in assembly process. The key point is some related dimensions of different component or part in assembling process. The assembly dimension chain, it is formed by some related dimensions in a part design. It is formed by some related dimensions of different component or part in assembly process. And the last one, design dimension chain. It is formed by some related dimensions in a part design join. The join is composed of many letters D, R, A, W, I, N, G. The design dimension chain, it is formed by some related dimension in a part design join. And the second is classification according to geometrical characteristics of the dimension chain. According to the geometrical characteristics of dimension chain, and the first one is length dimension chain. The length dimension chain, the key word is length, which means each dimension in a dimension chain is a measure of length. In this form. Only length, not angle. This one is not the length dimension chain. The length dimension chain, which means each dimension is a dimension chain, is a measure of the length. Each dimension in the dimension chain is a measure of the length, which is classification according to geometrical characteristics of dimension chain. The first one is length dimension chain. Each dimension in a dimension chain is a measure of the length. Is the measure of the length. Is the measure of the length. And the second one is angle. Composite to the length, angular dimension chain. Well, each dimension in the dimension chain is a measure of the angle. Well, maybe this one. Each dimension in the dimension chain is a measure of the angle. And so according to the geometrical characteristics of dimension chain can be divided into two, which means the first one is length dimension chain, while each dimension in the dimension chain is a measure of the length, and the second one is the angular dimension chain, while each dimension in the dimension chain is a measure of the angle. And this one is not included in the classification of geometrical characteristics, and the design dimension is included in this one, design dimension chain. So if we classification according to space position, the dimension chain can be classified as linear, planar, and special dimension chain. And it can be classified by the keywords linear, planar, special. The linear dimension chain, while all component links are parallel to the closed link, while all component links are parallel to the closed link. And we have shown this one. For example, in this figure, the linear dimension chain, the linear dimension chain, and it's also the length dimension chain, where means each dimension A1, A2, A3 in the dimension chain is a measure of the length. And also, it is linear dimension chain because all component links A1, A3 are parallel to the closed link A2. So in this figure, it is linear dimension chain. Now this is classification by the space position. And the second one is planar dimension chain. If all the dimensions in a dimension chain which comprise both linear and angular dimensions, both include linear and angular dimensions, are located in the same or parallel planes, dimension chain is called the planar dimension chain. While the planar dimension chain include the length dimension and the angular dimension, and they are in the same plane, then it's called the planar dimension chain. And the last one, the special dimension chain. While each dimension in a dimension chain is not in the same plane or mature parallel planes. And the special dimension chain is opposite to planar dimension chain. And in the planar dimension chain, all the dimensions are in the same plane. And the special dimension chain, the difference between this one and this one is the special dimension chain, while each dimension in the dimension chain is not in the same plane or mature parallel planes. So we have then some classification of dimension chain. At the beginning, we have then the definition of dimension chain and the increasing and the closed dimension. The component and the closed links and the increasing and the component links can be divided into increasing links, which can be denoted by this symbol, and decreasing links represented by this symbol. And then the classification of dimension chain, which can be classification according to the function of dimension chain. The function of dimension chain, which can be classified into typological dimension chain, where the dimension chain formed by some related dimensions of a single component, and the assembly dimension chain, which means it is formed by some related dimensions of different components or parts in assembly process, and the design dimension. And the design dimension chain, it is formed by some related dimensions in a part design join. The design dimension, it is formed by some related dimensions in a part design join. And the second classification is according to the geometrical characteristics of dimension chain. Then first one is length dimension chain, where each dimension in the dimension chain is a measure of the length, and the second is the angular dimension chain, where each dimension in the dimension chain is a measure of angle. And the third classification according to the space position. The first one is linear dimension chain. The linear dimension chain, where all component links are parallel to the closed link, and we have few example. And the second is planar dimension chain, where all the dimensions in a dimension chain which comprise both linear and angular dimensions are located in the same or parallel planes. The dimension chain is called the planar dimension chain. And the last one, spatial dimension chain, where each dimension in the dimension chain is not in the same plane or mature parallel planes. So up to now we have learned some key points, key definitions of dimension chain, definition, component links, and closed link. Component links can be divided into increasing and decreasing links. And then the three methods to classification of the dimension chain. And the next one we will go to the calculation formulas of dimension chain. Calculation formulas of dimension chain. How we calculate the dimension chain. How we draw the dimension chain. Before we only showed the dimension chain, but how we calculate, how we draw the dimension chain by ourselves, how we calculate the tolerance by ourselves. And this PPT will tell this topic, will talk about this topic. The calculation of the dimension chain is to calculate the basic dimensions, tolerance, and deviations of the closed link and component links. There are two methods to calculate the dimension chain. The calculation of dimension chain is to calculate the basic dimensions, tolerances, and the deviations of the closed link and the component links. There are two methods to calculate the dimension chain, and the first one is extreme value method. Extreme value method. The method is used to analyze and calculate the relation of closed link to component link when each component link is in the state of extreme value, minimum or maximum. This method is simple and reliable, but it has two strict requirements for the component links. Basically, almost all the operation dimension chains are calculated by the extreme value method. So repeat it again. The method is used to analyze and calculate the relation of closed link to component link when each component link is in the state of extreme value, maximum or minimum. This method is simple and reliable, but has two strict requirements for component links. And almost all of the operation dimension chain are calculated by using this method, the extreme value method. So the first is basic dimension of a closed link. How to calculate the basic dimension of a closed link. The basic dimension of closed link equals to the difference between the sum of basic dimension of increasing link. Increasing link we have named by this one, and the summation of basic dimension of the decreasing link by this one. Generally speaking, if there are some decreasing link in the dimension chain, then we will give it a symbol. This symbol, negative symbol. And if there are some increasing links, we will give it this positive symbol, and we will not write this positive symbol. Then the closed link equals to the equals to the increasing link plus this one, while the decreasing link has a negative symbol. And then we come out this equation, and this symbol, negative symbol, it can be seen comes out from the decreasing link. Basic dimension of closed link equals to the difference between the summation of basic dimension and increasing links and the sum of the basic dimension of the decreasing links. We have seen the example before. Well, A1 equals to A2 plus A3. Well, in that example, the A2 is the closed link. We will represent by A0. So we rearrange this equation. We will get A0 equals to A0 equals to A1 minus A3 minus A3. And in that example, the A0 is the closed link, and the A1 is the increasing link, and the A3 is the decreasing link. If we have many components, many increasing link, we use this symbol, summation. And if we have many decreasing link, we have this symbol, summation, and then this one comes out. So everyone understand this?
Yes, Laoshi.
So it's basically, we only have this symbol plus, but we should add a negative symbol to the decreasing links. We have increasing by this symbol, and we have decreasing, AI. By this symbol, if we have many, we use this symbol. But we add a negative symbol to the decreasing links, and then we plus them. It is equals to, if we rearrange this one, it equals to this one. This one, and this one is equals to this one, which means the basic dimension of closed link equals to the difference between the sum of basic dimension of increasing link and the sum of the basic dimension of the increasing link. This sum and this symbol equals to the decreasing link, and this, and the middle should be a plus sum, which means sum. So I will complicated. So in this figure, in this equation, well, I0 is a basic dimension of closed link, and the AI with this symbol, with arrow to the right side, the basic dimension of increasing link A with this symbol, decreasing link, and the N, all the increasing link in the dimension, and M, all links in the dimension chain. M, all the links in the dimension chain. Well, and this M plus M minus 1, we exclude the A0. So it's from N plus 1 to M minus 1. Well, the M minus 1, which means we have exclude the closed link I0. So if we plus M, if this one plus the closed link only have one closed link, this one, then we have the total number of all links in the dimension chain, M, and we only have N number of increasing link, and this is the number of decreasing link. So this equation is clearly not complicated. Then we will go to the next chapter. So we take this for example. Well, I0 is the closed link, and the basic dimension of the closed link can be calculated by, we have the increasing links minus the decreasing links. Because in this figure, if this dimension is a constant, then I0 and this dimension will variation in the opposite dimension. So to I0, this dimension is decreasing dimension. We use this and it has this symbol, arrow to the left side. This one is a decreasing dimension, and this one is an increasing dimension. So we can calculate the dimension of closed link by this one minus the decreasing dimension. So we have learned this one by definition and by example. The second one is limit dimension of closed link. We just learned the basic dimension of closed link. So what is the limit dimension of closed link? Which means the maximum dimension of the closed link equals the difference between the sum of all maximum dimension of increasing link and the sum of all minimum dimension of the increasing link. This is the limit dimension. It is upper limit dimension, which can be calculated by the summation of maximum dimension of increasing link and the summation of minimum dimension of decreasing link. Because we have this equation, and if we want we want the biggest I0, then this part may be the maximum and this one may be the minimum. Then we get the I0 max. Which means the max dimension of maximum dimension of increasing links in this part, maximum, and minus the minimum dimension of decreasing links. Then we get the maximum limit of the closed link. We use a which means this one, which means we use a maximum value minus a minimum value. Then we get a maximum value in the right side. Opposite in this one, if we want to calculate the minimum of I0, then we use the minimum minus the maximum. Then we get the left side, we have the minimum value. Well, the minimum value is, and this one is the minimum, and this one is the maximum. We use minimum minus maximum, we get the minimum value. So the limit dimension of closed link is the maximum dimension of closed link equals to the difference between the sum of all maximum dimension of increasing link and the summation of all minimum dimension of decreasing links. This can be represented by this equation. And at the opposite we get the minimum dimension. Use this equation. So we have named the basic dimension and the limit dimension of closed link. Then we have the upper and lower dimension of closed link. The upper deviation, we have named the maximum dimension. Then we name the upper deviation of closed link equals to the difference between the sum of all upper deviations of increasing links and the sum of all lower deviations of decreasing links. This equation is similar to this one. If we want to get the upper value, we use the upper value minus the lower value, which means we use the maximum value minus the minimum value. And if we want to get the lower deviation, we use the lower value minus the upper value. Use this one. This equation is similar to this one. In this equation, ES0 and EI0 are the upper deviation and lower deviation of closed link. Upper and lower, this is lower, this is upper deviation of closed link. And this one and this one are the upper deviation, this upper deviation, this one upper deviation, this one lower deviation of increasing link. And this one, these two are the upper deviation and the lower deviation of decreasing link. So this is the deviation range of the upper and lower deviation of closed link. We can calculate it straightly, because if we want to get upper deviation, we use the upper one minus lower one. If we want to the lower deviation, we use the lower one minus the upper one. Similar as we want to get the maximum value, we use maximum value minus the minimum value. And if we want to get the minimum value, we use the minimum value minus a maximum value, then we get the minimum value. These equations are similar to each other. The last one is the tolerance of closed link. Tolerance of closed link. The tolerance of closed link equals to the sum of tolerance of all component links. Because the closed link is formed by component links, so the tolerance of closed links equals to the sum of tolerance of all component links, which can be calculated by this equation. While T0 and Ti are the tolerance of the closed link, this is the closed link, and Ti is the tolerance of the component link, Ti, which means the tolerance of closed link, T0, the left side of this equation, equals to the sum of the tolerance of component links, the right side equation. This equation comes out the definition of closed link. We have named that closed link is the last formed dimension in assembly process or machining process is called the closed link because the closed link comes from the component links. So therefore, the tolerance of closed link is calculated by the summation of the tolerance of all component links. So up to now, we have learned the dimension chain, the concept of dimension, and the classification, and the classifications by many methods. And we have learned the calculation formulas. Calculation formulas of dimension chain. We use the first method, the extreme value method, and this method of almost of the operation dimension chain are calculated by using this method, extreme value method, and the extreme value we have used in the equations. And the basic dimension of closed link, which comes out, which computed by the increasing minus the decreasing links, and the limit dimension, we use the extreme value, the max, extreme value, the minimum, extreme value, the minimum, extreme value, the max, to calculate the limit dimension of closed link, and then the upper and lower deviation of closed link. We also use the extreme value, upper deviation, the lower deviation. They are all lower, upper, they are all the extreme value, and this one tolerance of closed link. The tolerance of closed link equals to the summation of tolerance of all component links, because the closed link comes from the component links. So we have learned a lot. So this we have learned these equations, these definitions, and it is important in this class, and it is used to draw the dimension chain and to calculate the dimension chain. So if you have some questions, please ask me, and we will talk about it because it is very important. And the next class, we will learn how to calculate the dimension chain. Use these equations. The extreme value is the most important method because it is almost all the operation dimension chain are calculated by this method. So please pay attention to this method. And all the equations, if you have some questions, please ask me, and we will talk about it again. So it's time to have a break. Please come back at 10:30.
Okay, 老师。
So let's back to the class.
老师 ，OK。
Okay.
老师。
This chapter may be some difficult because a lot of equations. But for mechanical engineering, these equations are very important, especially the different dimension chain, calculation of dimension chain, and especially the extreme value of this method, extreme value of the method. So we have learned something about extreme value method, including basic dimension of closed link, limit dimension of closed link, and the upper and lower dimension of closed link. So, and the tolerance of closed link. So, have any questions about these equations? If you have any questions, and can tell me, and I will explain it again. So if next, maybe later I will use example to explain it again. Maybe it's okay, and we'll go to the next method, the probability method. Probability method is the method used to analyze and calculate dimension chain based on the probability theory. It is mainly used for the dimension chain with many component links. And you can see this equation is very simple compared with this and this one. So if there are many dimensions, that the dimension chain contain many component links, then the probability method can be used to calculate the basic dimension of closed link, and they have the same equation form with compared to the extreme value method, while the first part of the right side is the increasing link, and the second part is the decreasing link, and we plus them, but the decreasing links we use a negative symbol, this one. And the tolerance of the closed link can be calculated by the square, by this form. Generally speaking, we usually use the extreme method. As we mentioned, almost all the operation dimension chains are calculated by the extreme value method. So this method is the probability method is very important and not very simple and not very important compared to the extreme value method. So we have paid much attention to the extreme value method to calculate the basic dimension, the limit dimension, the upper and lower dimension, and the tolerance dimension of the link. So we have learned much of the dimension chain. So in practical engineering, in the practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical engineering, we use the extreme value method. In practical the engineer are asked to calculate the dimension chain. So we have this example as shown in this figure. The dimension 40, the upper dimension 40, the upper deviation is 0 and the lower deviation is 0.16 is this one. And the 10, 0, and lower deviation is 0.3 are the design dimensions. This one and this one design dimensions. In this figure, in this part, the dimension of this part is inconvenient for measuring because it is in the hole. It can only be measured indirectly by measuring the depth L1 of the hole. So the question is to try to find L1 and its deviation. We know this dimension, the total dimension and the part of the dimension. And our question is to find the L1 and its deviations. So how to use what we have learned to figure it out, to answer the question? The first step is to draw the dimension chain and determine closed link, increasing link. In this figure, we have learned that this L0, it is inconvenient to measuring. So this dimension L0 is closed link because it is inconvenient for measuring. It is formed naturally if we have L2 and L1. So L0 is the closed link. So the first step to draw the dimension chain is to determine which one is the closed link. So in this figure, because the L0 is this dimension is inconvenient for measuring, so the L0 is a closed link, and the L1 and L2 are the component link. And the L2 is the increasing link because when L2 increasing, if it's longer, then L0 will be a larger number. So L2 is an increasing number, increasing component. And if L2 is L2, which equals to L0 plus L1, if L2 is a constant, then L0 and L1 will vary in the opposite dimension. So when L0 is a closed link, then L1 will be the decreasing link. So we're clear. This dimension L0 is the closed link, L0, and 40 is the increasing link. 40 is L L2 is the increased link. So L2 equals L0 plus L1. L2 equals L0 plus L1. So L1 is a decreasing link. L1 is decreasing link, closed link, decreasing link, increasing link. To calculate the basic dimension and its deviation, our question is to calculate to find L1 and its deviation and the basic dimension and its deviation by the form. We have this one, L2 equals to L0 plus L1, and then we rearrange the equation. We get L1 equals to L2. We move it to the right side. Then we get L0 equals L2 minus L1. And the basic dimension of L0, F0 is 10, L2 is 40, and we want to calculate L0, and we arrange this. We get L1 is 40 minus 10, and we get 30. We arrange this one. We get L1 equals to L2 minus L0, and the basic dimension of L2 is 40, and the basic dimension of the closed link is 10. Then we get L1 is 30. So the first question has found L1. L1 has been finished, has been calculated, and then but formula. This one has mentioned before. By the extreme value, use this equation. The upper one means the upper deviation of closed link equals to the difference between the sum of all upper deviation of the increasing link, all upper deviation of the increasing link, this part, and the sum of all lower deviation of the decreasing link, decreasing link. So we use this equation, apply it to this example. So the closed link, the upper deviation of the closed link equals to the L2 minus L1, which means this one means the upper deviation of L2 of this dimension, and this one means the lower deviation of this one. So these two equations have similar form. L2 minus 1, 2 minus 1, we get the closed link value. 2 minus 1, 2 minus 1, get the closed value. So institute ES2 means the upper deviation of L2, is 0, which means 0. And the lower deviation of L1, the lower deviation of L1 is also 0. the null deviation is 0 because we haven't give the value because it is the last one to be calculated. And if we applied this equation, we combine this equation, combine this one, combine these two equations, and what we know, we will get this one equation. The upper deviation of L1, and then therefore we get the deviation of L1 is from 0 up to 0.14. This example is a small difficult, and everyone should pay attention to this equation. And if you have learned these knowledges carefully, and you will use this equation directly to figure it out, to figure this question, figure it out directly. And maybe it's not difficult because all the answers are calculated by using these equations directly. And if we have understand the equations, then we will figure it out. So today, we have learned something very important. Concept of machine allowance. I've learned the concept of machine allowance, which
Lavshi,
is.
I have a question. Lavshi,
What?
I have a question. How can I get sure which one is the lower, which one is the decreasing link and which one is the increasing link?
Maybe you can see it clearly.
Lavshi, just show the last slide. The step
Last
one.
slide.
Yes.
Last one?
No, Lavshi. The calculation one, the example.
The last example.
Yes, that math.
The last example, you can figure it out by using these equations. And if you understand these
Lavshi,
equations.
I could not understand the step one. The step one. Yes, step
What?
one. How can I find step one? How can I find out which one is the closed link and which one is the increased link?
Okay. I understand you. So everything should come out from the definition. Everything should come out from the definition, and which one is a closed link, which one is a component link. They should be come out. They should be from the definition of closed link and component link. So we have to see what is closed link and what is component link. So you can see in the last formed dimension in assembly process or machining process is called the closed link. The last formed dimension. The last formed dimension and all the other dimensions are the component link. So the first step is to say which one is closed link, and is defined by the last formed dimension. The last formed dimension in the assembly, in the process. So we should to say which one is the last dimension. So in this example, in this example, I've told you that in this, this dimension is inconvenient for measuring in the process. Inconvenient, which means it is the last one formulated in the machine process because it is inconvenient for measuring. It is inconvenient for measuring. So L0 is the last formed. So L0 is the closed link. And all the other dimensions, L1, L2, and they are the component links. Because in the dimension chain, we only have one closed link, and it is L0. Because L0 is inconvenient for measuring, and it is formed in the last step. In the last step, because we can see in this figure, we first in the machine process we get the we should get L2, get the dimension 40 using the machining process, and then we get this dimension, L0, L1, get this dimension, use process this dimension. We have this hole and this dimension. It comes out naturally. We use L1 minus L2 and the L0 comes out naturally. So L0 is the last one we get. So L0 is the closed link.
Lavshi, so can I say closed link is inconvenient for measuring?
Yeah.
Okay. Thank you, Lavshi.
So maybe understand the process, the machining process, which one is the first, which one was the L2 is the first one, and then we get L2, and the last one, L0 comes out naturally. So L0 is the closed link. And you say, okay, that's fine if you understand, if you think the if you think the closed link is inconvenient for measuring, it's okay in some cases. So I will recall what we have learned, and maybe from the first this class, closed link dimension chain. The definition of dimension chain is a closed dimension diagram. We have seen in all the examples, the dimension chain is closed dimension diagram, which is composed of a group of related dimensions connected in the end-to-end sequence way. Three key points: closed group of dimensions and end-to-end sequence. And we have the dimensions can be composed of closed link. And one student has asked, what is closed link? And usually it is inconvenient for measuring. And several component link only. There is only one closed link in your dimension chain. If we have the closed link and all the other links are component links. For example, in this one, we have only one closed link, and all the other links are component links. And the closed link is a final step to know. The definition of closed link is the last form dimension in assembly process or machining process is called the closed link. And then we have some classification of dimension chain by the function of dimension chain that we classified into technological dimension chain, assembly and design dimension chain, and the classification by the geometrical characteristics, which can be classified as divided into length, angular, and design. This design is not right. Only two, the length and angular dimension chain, and the last one, classification according to the space position, which include the linear, planar, spatial dimension chain. And this part is very important, extreme value method, because almost all of the operation dimension chain are calculated by using this method, and all the dimensions of closed links are calculated directly. Only use these equations, and it is I think is maybe easy to understand. We use the basic dimension of closed link. We use the dimension of increasing link minus decreasing link. So another key concept is what is increasing link and what is decreasing link. What is increasing link and what is decreasing link. And we have seen this example. This dimension is a closed link. If we increasing this value this value will be increasing at the same time, so this dimension is increasing link. If this dimension is constant, this dimension is constant, then this dimension and this dimension, they will vary in the opposite dimension, which means if this one increasing, then this one will decreasing. So this dimension is decreasing links. And we have also named the limit dimension of closed link, which means the maximum dimension of closed link equals the difference between the maximum dimension of increasing link and the sum of minimum dimensions of decreasing link. We use the maximum value, maximum limit, upper limit. We use the maximum value minus the minimum value. Then we get the maximum value. And as opposite, if we want to get the minimum value, we use minimum value minus the maximum value. Then the upper and lower deviation of a closed link, similar to the limit dimension of closed link. The upper deviation of closed link equals to the difference between the sum of all upper deviations of increasing link and the sum of the lower deviation of decreasing links. If we want to get the upper deviation, we use upper minus lower. If we want to the lower deviation, we use lower minus upper. This is very important, which will be used in the example. And the tolerance of the closed link are calculated by this. The tolerance of closed link are equal to the sum of the tolerance of all component links. It's easy to understand. And I have to tell you the important one further step to classify which one is a closed link and which one is a second link. And I also told you the dimensions of L1, and there only remain one equation to be applied to calculate the deviations of L1. So if you understand these equations, and the answer will be comes out naturally. And what I want to say is maybe this example will appear again in the final examination. And if it is in the final examination, the detailed steps should give to me how to calculate L1, how to calculate the basic dimension and its deviation of L1, not in this form, but in detail. The detail means you should write this equation on the paper and then use this equation to calculate the values. Only one steps are remained. So the last 3 class, we have learned something about machining process and planning. But we have learned something about the planning, machining process and planning. Some key concepts will be repeated again, and then the class will be finished. We have learned the definition, some basic concept, production cost, process and process cost, and the working operation. Working operation is very important in machining process, and it has 4 key factors. Same operators, same workpiece, and the same working place, and continuous. And we have seen some videos for every machining process, one by one. And the element of process course, including working step, it can include continuous working step and the compound working step, and also working stroke. It is the manufacturing process that is completed by cutting the surface one time with the same cutting tool and the same cutting parameters. Working stroke and setting up. The working position. Then the next production program and the production type. They have an influence the production organization and management layout of workshop, process method, the manufacturing equipment to be used and the technical requirements for operators. Production program. And we have then how to calculate the production program N. Also then the production type including 3: job production, batch production, and mass production. We also render this figure, this table, step by step in detail. And some important concept. And we also learn the procedure of process planning. What is process rule? This is a document. Some document is called process rule. The document is relevant content to the manufacturing process of a product are specified in the form of document expressed by chart, tables, and words. And the document is called the process rule to guide the process, to guide the machining process, which is called the process rule. The function of process rule, the first is to guide the production costs, and the second is basis of production preparation, and the third important technical reference, and the fourth main means used to store and exchange technology. We also need some original information required to make out a process rule. We have 6 key informations: part drawing and assembly drawing of the product, production program and production type we have named just now, and quality standards used to inspect products, and blank production situation, and production condition of the factory. The last one, development of current production technology at home and abroad. And also then the procedure of process planning. The first one is technological analysis of of the work part to be machined. And the second process is selection of blank. Third is drawing up process rules, and the last one determining equipment and tuning needed in each working operation, and the concept of working operation we have learned just now, and the fifth, specifying technical requirements and the inspection means used in key operation, and determine machining allowance, include calculating operation dimensions and their tolerance for each operation, and the tolerance machining allowance we have named just now. Machining allowance, tolerance, and then specify cutting variable for each operation. It is related to the machining allowance. And then we have named the datum and its classification. The datum is a very key point to this class, which means points, lines, and surfaces used to determine the position of other points. So we have learned something, we have learned much of this class, and I will send the PPT to the WeChat group, and some of the points, some of the content will be appearance in the final examination, especially the last example we just show this one, and the final examination will come out from the PPT. So please pay attention to the contents. So it's time to say bye. Class finished.
Bye bye,
Oh,
Laoshi. Thank
really?
you.
It's okay, Lashi. It's okay.
Thank you. See you.
Okay. See you,
See you,
Lashi.
Laoshi. Thank you.